Alright, so module 3.10, I know, what do you know? So here we're looking at, we're given some piece of information, and we want to find as much information as we can about it. Okay, we need at least 4 for each one. The type of things we can find: a table, a graph, explicit equation, recursive. We're given a recursive here, so we couldn't do that one. The constant ratio or difference. Remember, ratio if it's geometric, difference if it's arithmetic. Okay. Any terms that are missing. Okay, type of sequence, or a story to go along with it. So you need to pick 4 of those to kind of go there with us. So let's go. So if I'm looking at this, right off the bat I can tell you it's a +4. So this is an arithmetic sequence with a difference, a constant difference of 4, because we're adding 4 each time. Okay. Could I make it an explicit equation? Not quite, but almost. I could make a table though. So I'd start and I'd go 0, 1, 2, 3, 4. And I know that at f of 1 we're at -12. And I also know that my pattern is adding 4. So that would be -8, -4, 0, and so on. But I can also back it up and figure out that that's -16. With that, I can do my explicit equation. I could go y equals, we started at -16, added 4 x amount of times. Okay, already I've got 4 things right there. But I could also graph it. Okay, 0 down here at -16. And 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So that's actually where my x-axis would be. Okay, and I could graph these. So right here, then up to here, here, and so on. Okay. I could also make a story. You know, I started out on day 1 of my new training, and I was, let's see, no, I'd probably go something like this. So it cost me $12,000, we'll just say 12 to make it easier, $12 to buy my food truck and to get stocked. Every day, you know, I try to sell $4 worth of food. So how long till it takes me to make up my pay, or something like that. Okay, so that would get us the story context. It's pretty much everything we can do except any terms that are missing, but we don't really have any, so we're good. Okay. Alright, number 2. So we know that the first 5 terms of a sequence are 0, -6, -12, -18, -25. Now it says the first 5, so that means if I make a table, that 0 is actually 1, 2, 3, 4, 5. Okay, so we're subtracting 6 each time, right? So there's my constant difference is 6, that's one thing. Makes it arithmetic, that's another thing. I can graph that. Okay, so at 1 we were at 0. At 2, 1, 2, 3, 4, 5, 6. At 3, 1, 2, 3, 4, 5, 6, 12 more. And 1, 2, 3, 4, 5, 6. I think that's supposed to be 24, by the way. And so on. There's my graph. Okay, now can I come up with equations? Sure. If I jump back to 0, that would be a +6. So my explicit would be y equals 6 minus 6x. My recursive would be f of 0 equals 6, or f of 1 equals 0. And f of x equals f of x minus 1 minus 6. Because that's our growth. What else? We've got equations, table, graph, constant, type, and then just a story if we wanted to make one up. Something about losing money. You know, my food truck has done so horribly that it cost me $6. I lose $6 because my ingredients cost more than what I'm making. Something like that. Okay, number 3. So we know the explicit formula is this, which we could rewrite as f of x equals, or y equals, negative 10 times 3 to the x. Same thing. So I know it's right off the bat, we're multiplying and it's an exponent, so it's geometric. Okay, what's my constant ratio? Well, this is our growth number, that's what we multiply by, so it's positive 3. Okay, could I make my recursive? Yeah, easy. F of 0 is going to equal negative 10, because that's the starting number, and then f of x is going to equal f of x minus 1, and I'm going to multiply by 3. So there's my recursive. Could we make a table out of that? Yeah. Start at negative 10 times by 3, negative 30, negative 90, negative 270, and so on. Could we graph that? Yeah, easily. That would take a lot of numbers, but it's basically going to be going down pretty quick, right? So, there we go. See, so if we're given one piece of information, we should be able to very easily find some other pieces that would work. And you can write up a story. This one would be more difficult, something about starting with negative 10 and then we triple it every time. So, but that negative kind of makes it tough to come up with a story problem that works. But that's the gist of it. Okay? So let's keep going. So the first 4 terms, 2, 3, 4.5, 6.7. So could we add a number? Well, 2 plus 1 would get us 3, plus 1 wouldn't get us 4.5, would it? It would get us 4. So it's not arithmetic. Is it geometric? Well, 2 times what will give us 3? And then 4.5, and then 6.75. If you're not sure, just go 3 divided by 2. That would be 1.5. So 2 times 1.5, that's 0. 1, 2, 3. Bring the decimal down, 3. What about 3 times 1.5? Oh, let's do it on the top, huh? Let's see if this works. So that would be 15. 3 times 1 is 3, plus 4 is 4. Bring the 1 decimal. Yeah. So we're multiplying by 1.5. So our constant ratio is 1.5, making this geometric. Okay. Then I can turn it into a table. So we'd have 1 and 2, 2 and 3, 3 and 4.5. Our fourth term would be 6.75. Could we go backwards? Well, yeah, we could. What times 1.5 would give us 2, though? That's kind of a tough number to figure out. So I'd go 2 divided by 1.5 would be 4/3. 4/3 times 2.5, 1.5 would give us 2. So there's a table. Could I graph that? Yeah, easily. 4/3 is 1.3, so slightly above that. Then 1, 2, 2, 3, 3, 4.5, 4, 1, 2, 3, 4, 5, 6.75, so almost 7. So you should see a slight curve to it. Okay, can we make an explicit equation? Yeah. Y equals, we start with 4/3. We're multiplying by 1.5 to the x. Recursive, just as easy. F of 0 equals 4/3. And f of x equals f of x minus 1 times 1.5. Okay, there we go. So, let's take a look at 5. So we know the sequence is arithmetic. f of 3 equals 10, and f of 7 equals 26. So, we know it's arithmetic, we can make a table, right? So 0, 1, 2, 3, 4, 5, 6, 7. 7 is 26, 3 is 10. So, what do we know? Not much so far, but we can try to figure things out. Let's see if we can figure out these missing terms. So remember, the way we do that is at arithmetic mean. So we go 26 minus 10. Okay, that gives us 16. Then we've got 1, 2, 3, 4 jumps. Divide that by 4, we get 4. So we should be adding 4 each time. So 14, 18, 22, 26. So if we work backwards, that would be 6, 2, negative 2. So easy to graph, right? So 0, negative 2, 1, 2, 2, 6, and so on. Okay, we found the missing numbers, found the growth and the starting, so explicit, f of x equals negative 2 plus 4x. Recursive, f of 0 equals negative 2, f of x equals f of x minus 1 plus 4. What's our constant difference? It's 4. And we can make up a story problem to go along with it. So I'll leave that to you guys' imaginations. So it looks like we're halfway done. Let's keep on moving. Alright, here we go. So I would start probably with making a table. Okay. So we have figure 1, we'll call that 0. We have, let's see, we want perimeter, don't we? So it would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So pretty easy to see we're adding 10, right? Why are we adding 10? Well, think about it. How many? We went from 1 to 3 to 5, so we're adding 2 of these. Okay, but we've already got one of the borders counted for, because we're only dealing with perimeter. We don't deal with that or that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Because we have the 6. Oh, dang it. Duh. We'd only be adding 8, wouldn't we? Because it is only the perimeter. Mistakes abound here. So that one's still 6, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There, so we'd be adding 8. Because like we said, we don't count the middle ones. So we're just going 1, 2, 3, 4, 5, 6, 7, 8. And then that gets extended to that end. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay? So, it's arithmetic with a constant difference of 8. We have our starting, so f of 0 equals 6. So f of x equals f of x minus 1 plus 8. So that's our recursive. So our explicit, we simply go, we started with 6, added 8, repeated addition means multiply by the variable. We could draw a graph, which would shoot up something like that. That would be 6, that would be 14, and 22. Okay, so more than enough for us. Alright. It says now, it is a sequence where a sub 1 equals 5 and the constant ratio between terms is negative 2. So, the constant ratio is negative 2, which tells me it's geometric. Now, they use some weird notation. That a sub 1 simply means, in their sequence, the first term is 5. So I can make a table by multiplying by -2. So -10, +20, -40. Going backwards, -2.5. Okay. That's all that notation meant. I don't like it, so we don't use it much. Okay, so recursive equation, f of 0 equals -2.5, f of x equals f of x minus 1 times -2. Explicit, f of x equals, we started at -2.5, we multiplied by -2 x amount of times. So it's the exponent this time. The exponent this time. Then what else could we say? We could graph it. The thing with geometrics is the graph is going to need to curve. Okay, so it curves something like that. And you'd obviously have your points and whatnot here. Okay, there we go. Alright, let's take a look at 8. Okay, here we go. I know that the sequence models the value of a car that originally costs $26,500 but loses 10% of its value each year. So here's a story. Now, whenever we're dealing with percents, especially with original costs and stuff like that, you should be keyed into the fact it's going to be geometric. Because we don't add percents, we multiply with percents. They're a portion of. So multiplication and division is how we think of it. So we make a table. So it originally cost $26,500. But we lose 10%, so we're subtracting 10% of that. Well, how do we figure out 10% of our number? Well, we just take off one of the zeros. So it would be 2,650 is what we lose, which we'd subtract from that. But we're not going to just keep doing that, because with percentages, they change as our number changes. So that's why it's not arithmetic. So here's an easier way to think of it. Okay, we want to know its value. So to do that, 26,500 would be 100% of its value, right? We're not losing any of that. Well, how much percent is left if we lose 10%? 90%. So if we multiply this number by 90, it's going to give us the value of the car with less 10%. So that's the way we want to attack it. So let me grab my calculator. So we think of that as 0.90, right? Or just 0.9. So we're multiplying by 0.9%. Well, 0.9. So right here, I already have enough information for my recursive, right? F of 0 equals 26,500. F of x equals f of x minus 1 times 0.9. My explicit would be y equals 26,500 times 0.9 to the x. Could I make a graph? I could start it. That's 26,500. And then it would slowly dip down and keep going that way. Okay, we know it's geometric. Okay, we know its constant ratio is 0.9 to what we're multiplying by. So we could just finish the table. So 26,500 times 0.9 would give us 23,850 after that first year. So after a year of you driving it around, that's how much you could sell it for if you kept it in good condition. Do it again, you get 21,465. Do it again, 19,318.5. Do it again, 17,386.65. Okay, so 3 years, 4 years, 5 years, 6 years. 5 years, 15,647.99 if I round. Then 14,083.19. So after 6 years, we still have over half the value of it. Okay? If we keep going, the next year is when we are under half the value. So after 7 years of owning the car, it's worth less than half. Okay? So then 8 years, 9 years, 10 years, 11 years, 12, 13, 14, we're down to 6,000. 14 years, it's 6,062. So 15, 16, 17, so it's going to stay in those thousands for some time. Okay, it would take quite a bit of time for it to get down to almost $0. Okay, because it's going down at such a low rate. Okay, so there we go. Alright, number 9. The first term of the sequence is -2. So we'll start off with our table. So we know that this first sequence is -2. And the fifth term is -1/8. What do you know? Okay, this is those geometric means. Okay, this is the ones that got tricky. So we know it's geometric. We don't know our ratio yet. We don't have enough information to figure out anything else. But I do know that we're dealing with our geometric means here. So we take this one and divide it, so -1/8 divided by -2. In other words, -1/8 times -1/2. So the negatives cancel, become positive 1. 8 times 2 is 16. Okay, so we've got 1/16. But now we've got to split that up into 1, 2, 3, 4 jumps. Well, how do we split that up? We take the 4th root of it. So when we're dealing with fractions, we take the 4th root of the top, the 4th root of the bottom separately. The 4th root of 1 is 1, because anything root of 1 is always going to be 1. And you can use a calculator to help you figure this out if you need to. They have ways to do this. Okay, so then I take the 4th root of 16, and I believe that's 2, because I think 2 times 2 times 2 times 2 would give us 4, 8, 16. Yeah. So if I took the 4th root of that, 16, it gives me 2. So we are multiplying, our constant ratio is 1/2. That's what we're multiplying by here. So let's get rid of that. We times by 1/2. So this would be -1, -1/2, -1/4, -1/8. Going backwards, -4. So we can graph that, right? 1, 2, 3, 4. So 0, -4, 1, -2, 2, -1, 3, -1/2. So it's going to keep going down like that, but never quite getting to 0. Now recursive, f of 0 equals -4. F of x equals f of x minus 1 times 1/2. Explicit, f of x equals, we started at -4, we're timesing by 1/2, x amount of times. And we could try to come up with some story problem. That would be a tough one to come up with. But we've got plenty of things. 1, 2, 3, 4, 5, 6. We did 6 different things there. Alright, let's take a look at this last one now. So I know a graph of the sequence is this. What do we know? Well, we should be able to quickly make a table, right? We start at 0 and go clear to 15. We don't have to go that far. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's far enough. We start at 12. Then we go down to not quite halfway. Ooh, here we go. I know that that is 3. So at 3 we have 9. So at 6 we have 7. Okay. Oh no, that should be 11, shouldn't it? Not 12. That's what's throwing me off. Then I go to 9. See how I'm going down? Every time I go down 2, I go to the right 3. So at 9 it would be 5, and so on. So now, can we figure out what these other two pieces are? Yeah, we can do that arithmetic means, because I can see here it's a straight line, so it's going to be arithmetic Okay, with a constant difference of, that's what we're trying to figure out. So 9 minus 11 gives us negative 2. Negative 2 divided by 1, 2, 3 jumps would give us negative 2/3, or negative 0.66667, right? So negative 2/3. So we're subtracting 2/3 each time, which would make this 10 1/3. Then this would be 9 2/3, and then that would be 9, and so on. So then we'd have 8 1/3, then 7 2/3, then 7, then 6 1/3, 5 2/3, and 5, then, and so on, 4 1/3, and so on. So our constant difference is we're subtracting 2/3. So recursive equation would be f of 0 equals 11, f of x equals f of x minus 1 minus 2/3. Our explicit would be y equals, we start at 11, subtract 2/3, x amount of times. And we are done.